Welcome to 4.4, graphing sine and cosine functions. Before we actually graph, we're going to share out some of the basic rules for uh, your basic functions without any transformations, because most of what you're going to graph is with transformations, but thought we'd start with this first. So the domain for sine and cosine is all real numbers. You can put anything into either of them and you will get an output. And that output will be between -1 and 1, and including -1 and 1. Because remember, if you remember unit circle, none of your values are bigger than 1, and none of them are smaller than -1. Y-intercept for your sine function 0, for your cosine functions 1. If you think about it, if you put 0 in for sine is 0 is 0, and cosine is 0 is 1. Now the x-intercept looks confusing, but not meant to be. It's n pi, okay, for all integers n, because no matter, whether you put 1, 2, 3, -1, -2, -3, there's going to be an x-intercept of that value, as opposed to cosine, which is pi over 2 times n. If you think about it, if n is 1, and think about unit circle, sine of pi is what? It's 0. Cosine of pi over 2 is, it's 0. Okay? So what do you think about it? It's continuous the whole time. Both functions are continuous the whole time. Some of you will enjoy kind of how the graph looks, how they're continuous, which we'll get to later. Symmetry. Sine graph is symmetric over the origin, the cosine graph over the y-axis. And their extrema are both at 1 and -1, right? And the extrema for sine happens at x equal to pi over 2 plus 2 pi n, meaning any integer n, you'll have a max there. And also x equal to 3 pi over 2 plus 2 pi n for its minimum of -1. For your cosine function, close to the same, it's max of 1 at 2 pi n. And then min at -1 is pi plus 2 pi n. The n behavior does not exist, okay? As you go to infinity or negative infinity, it does not go to a specific value. There is no n behavior because the limit does not exist. And it oscillates between -1 and 1 the whole time. It's going to keep going up and down, up and down, up and down throughout, and forever and ever between -1 and 1. What I have here is your basic sine and cosine equations, okay? Y equals a times sine of bx plus c plus d, and then same thing goes with cosine. Each of the 4 letters has a different meaning and how it will change your graph. The first one is amplitude. Amplitude focuses on your a value, okay? Your a value is what's going to tell us your amplitude. And what your amplitude is half the distance between the max and min values of the function, or half the height of the wave. So I drew the basic trig graphs in red, okay, of sine and cosine. Now you might be thinking, Mr. Barton, you made all these up. How did you come up with these values? Well, remember your unit circle, okay? With your unit circle, you might think, what sine is 0? And it's 0. You might think, what sine of pi over 2? And it's 1. You might think, what sine of pi is? And it's 0. All of these values that I graphed, and these points I graphed, are from your unit circle. Okay? So that's where the basic trig graphs come from. Now, when we have an a value that's not 1, our amplitude is the absolute value of our a value. So it's 3 in this case, okay? So it's not going to change the fact that it's 0, 0, but at pi over 2, it's going to be 3 instead. And it's not going to change whenever it's at pi, because that's still going to be 0. But at 3 pi over 2, it's going to be -3. So be careful, because a common error is that people go up 3, but they don't bring it all the way down. Because remember, amplitude is half of the height of your wave, okay? That's an important part. I'm not going to graph this whole thing, but I'm going to do a couple parts of this real quick. So there, there, and down here. So it goes near. I'm sorry, I missed all the way down to 3, and there we go. Okay, and we'll keep going doing one of these. Yeah, so on and so forth. Okay, and here we have amplitude of 5. So we're going to start at 0, 5 instead, and it's going to go through 0 right here, and negative 5 right here. So it's going to go near. So on and so forth. Okay, so just keep drawing those points. Should I move that over a little bit? That's okay. And this keeps going. Anytime our graph has a negative in the front of its trig function, we're reflecting over the x-axis. So, and we have amplitude of 2 here, okay? When I ask for the amplitude, you better not say negative 2. It's 2, okay? Remember, you're measuring the height. Height is 2. Or, I'm sorry, it's half of your height, which is 2. So, instead of starting at 0, 2, like you normally would at 2 cosine x, you're going to start at negative 2. Put a value there, put a value there, there, there. And that's what the graph would look like. So it's reflected over the x. Now, period is a very important part that I am going to ask you over and over when we're graphing trig functions. And what is a period? It's the distance between any two sets of repeating points in the graph. Okay? So, what does that mean? Oop, I didn't mean to do that. So with sine function, whatever this distance is from here to here, whenever it starts making that same motion through that same point, like here and here, that's one period. For the case of cosine, usually the easiest way to tell one period is from here to here. Now, can you technically tell a period if I kept drawing this over and over again? If I said, hey, can I tell what the period is if I measure from here to here? Of course, sure, it's still going to be one period. And it's just with the basic starting value points of sine and cosine. Usually it's easier to start up here and start right there for sine. And the formula to find the period is 2 pi divided by the absolute value of b. B being the value that you're multiplying x by. Okay? Now, all the graphs we did so far is when b is 1. So all the periods of the first few graphs, if you want to label them, were 2 pi. Okay? So that's what we got so far. So we got sine of 2x. So what's your period? Period is 2 pi divided by 2, which is pi. Okay? So that means this motion will be a distance of pi. So I know I'm going to have 0, 0, and I know I'm going to have pi comma 0. So how I like to think of graphing these when they're this simple is all the original inputs divide by 2. So originally we had pi as another 0, right, than the other one. But if we do pi divided by 2, now pi over 2 is going to be our 0. Also, pi over 2 was, we got an output of 1 at pi over 2, right? Divide pi over 2 by 2, you get pi over 4. So it's going to be approximately right there. And then 3 pi over 2 divided by 2 is going to be 3 pi over 4. It's going to be approximately right here. So it looks something like that. Okay? And then once again, next period will be another pi later. All right? And halfway will be another 0. Same story as before. That's poorly drawn. It's embarrassing. Let's try that again. I went too far down, but you get the point. Okay? So the graph would look like that. Okay? Another thing we're looking for is frequency. Frequency is number of cycles the function completes in 1 unit interval. It's a reciprocal of period, okay? So in the last problem, when we had sine of 2x, it would be 2 divided by 2 pi, which would be 1 over pi. So what does 1 over pi mean? So if I were to go 1 unit from, let's say, 0 to 1 of our graph, our lovely shape of this will happen 1 over pi times. So it's not even like 1 unit's not even going to happen, not even half of this shape is going to happen for 1 unit, okay? So it's just going to be about that much is going to be its happening for our frequency. And we got this example right here, and we are going to do this one in class together, okay? We're going to guide, and I'll work with you on doing this. If you want to try this on your own, go for it, but do it in a pencil. Trust me. I appreciate you watching, and we'll see you in class. Bye-bye now.